Hello students, today's first question is, if k is equal to k1, k2, k3 so on up to kn belongs to integers, and k1, k2, k3 plus k2, k3, k4 so on up to kn minus 2, kn minus 1, kn is equal to 0. Then minimum how many entries ki must be 0, right? So I is equal to 1, 2, 3 must be 0 if there are total 12 terms. So these are basically n is given to be 12. So we need to find how many terms out of these should be equal to 0 so that this sum must be equal to 0. Now let us for example take first k1, k2, k3. Now if I put k3 equal to 0, then k1, k2, k3 will be 0. Second term k2, k3, k4 will be equal to 0, and k3, k4, k5 will be equal to 0, right? So in the same way, when I put k equal to 6 equal to 0, then the very next term will be k4, k5, k6, then is k5, k6, k7, then is k6, k7 and k8. So this means that if one entity is 0, then three entities are 0. We need to find the minimum how many entities must be 0. So there are 12 terms, and for every one term there are 3 entities 0. So 12 divided by 3 is equal to 4. So basically 4 entities must be 0 so that the sum should be 0. So right option will be option number B. The given relation n raised to power n minus 1 plus n raised to power n plus 1 equal to n square plus 1 whole square minus n square plus 1 is valid for n belongs to natural numbers if n equals to. Options are 3, 5, 1, both A and C. So we can simply put the values and check. Let us suppose we check for option 3. So this becomes, when n is 3, so this becomes 3 raised to power 2 plus 3 raised to power 3 plus 1, 4. This side this will be 3 square, 9 plus 1, 10 square, minus n square is 9 plus 1, 10. So this is 10. So this becomes 9 plus 81 equal to 100 minus 10. So this is 90 equal to 90. So this relation holds good for option number A. Now we'll check for option number B. Option number B is 5. So this becomes 5 raised to power 5 minus 1, 4 plus 5 raised to power 5 plus 1, 6. So here on this side this will be 26 whole square minus 5 square, 25 plus 1, 26. On this side I can take 5 raised to power 4 common. I will be left with 1 plus 5 square. On this side I can take 26 common, so I will be left with 26 minus 1. Now this is 5 raised to power 4 into 26 is equal to 26 dot 25. Or 26 gets cancelled, and 25 is, I can write 25 as 5 square, and 5 square will cancel 2 of the squares of this, so I would be left with 5 square equal to 1, which is not true. So I will cancel option B. Now moving to option C. Option C is 1 raised to power 1 minus 1, that is 0, plus 1 raised to power 1 plus 1, 2 equal to 1 square plus 1 is 2 square minus 1 plus 1, 2. So this is basically anything raised to power 0 is 1 plus 1. So here it will be 4 minus 2. So this is 2 equal to 2. So it stands true for option C also. So right option will be option D, both A and C. Total number of factors of a number is 24, and sum of its 3 prime factors out of 4 is 25. The product of all prime factors of this number is 1365. Then such a greatest possible number can be. So we have been given a lot of data. Let's try to break it. Now first it has been given that the product of 4 prime factors is 1365. So product of 4 prime factors is equal to 1365. So whenever we factorize it, so that will be, since the number is odd, so we can't have 2 in this combination. So 3 into 5 into 7 into 13. So this is equal to 1365. Now the very next thing we have been given that the sum of its 3 prime factors out of 4. Now 4 prime factors are this, 7, 5, 12, 13. So sum of 3 prime factors, so that is 5 plus 7 plus 13, which is equal to 25. Fine. Now total number of factors equal to 24. So we have been given n is equal to 24 of this number. 24 can be written as 8 into 3, or I can write this as 2 cube into 3, or I can write it as 2 into 2 into 2 into 3. Now we know that when we find the number of factors, so we add 1 to the power. So basically this is equal to 1 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 2 plus 1. Right? Now this means basically that n can be expressed as product of this. So this has been extracted from here, 3 raised to power p into 5 raised to power q into 7 raised to power r into 30 raised to power s. Now in order to have the greatest possible number, the power of 13 should be maximum. So I will assign this power to this. So this basically becomes 13 raised to power 2. Right? Now how I deduce this is basically, now let us suppose we have a number 24. Now this is equal to 8 into 3, which is 2 cube into 3. So I will write the total number of factors as this power plus 1, 3 plus 1 multiplied by 1 plus 2, 1 plus 1. So this is 4 into 2. So in all it has 8 number of factors. Now we have been given the total number of factors 24. I factorized it and then I made it in this form. So the number is in this form, 2 into 2 into 2 into 3. So I wrote it in this form. So this is basically I am reversing this sequence. Now 7 raised to power single 1 into 5 raised to power 1 into 3 raised to power 1. Now if you try to find the total number of factors, so that will be 1 plus 1. Then 1 plus 1, then 1 plus 1 and 2 plus 1. So it will become 24, which has been given to us. Now we need to find the number. So that will be equal to 15 into 7 into 169. Right? So when you multiply it, so this comes out to be 17,745. So right options will be option number A. The number of solutions set xy for the given equation, the equation is 4x plus 7y equal to 3, such that x is in between greater than equal to minus 99 less than equal to plus 99, and y is greater than equal to minus 100 and less than equal to 100. Fine. Now we need to find the solutions x and y. How many such solutions are possible? Now if I take x to other side, so this becomes 7y is equal to 3 minus 4x, right? Y becomes 3 minus 4x divided by 7. Now since xy belongs to integer, so that means x, I should put the value of x in such a way that this whole should be divided by 7. Now the range of x is minus 99 to plus 99. So I will check for the lowest. So first is y is equal to 3 minus 4 into minus 99 divided by 7, right? Now 99 into 4 is 396. So this will become plus 399 divided by 7. Now 7, 5, 35, 49 is 7. So y is equal to 57 when x is equal to minus 99. So this is one pair, minus 99 comma 57. Now for minus 98, so this won't be divisible again. So for 98, so we have to check for other values. Now the next value after minus 99 is when x is equal to minus 92. So 3 minus 4 minus 92 divided by 7. Now 92 into 4 is 368. So 3 plus 368 divided by 7. So this is basically 371 divided by 7, which gives me the value 7, 5, 21, 53. So the very next pair is when x is equal to minus 92, then the value of y is 53. Now from left hand side, from this inequality, for y equal to 99, it doesn't give me any integer number for y, right? So we'll check from 99. So the next value for which it gives me the value as integer is when x is equal to plus 97. So when y is equal to 3 minus 4, 97 divided by 7, right? So now we'll check for this. 97 into 4 is 388, and 3 minus 988, 388. 3 minus 388 is 3 minus 385. So when I divide this, so it gives me minus 55. So x is equal to plus 97 and y is equal to minus 55. So basically from minus 99, then minus 92, so on up to plus 97. Now the difference, so this becomes an AP. Now to find the number of terms, an is equal to plus 97. So basically 97 is equal to first term minus 99 plus n minus 1. The difference is minus 92 plus 4, this is 7. So this becomes 97 plus 99. So this is 196 divided by 7 is equal to n minus 1. So this implies 196 divided by 7 is 28. So n is 29. Right? So this means that basically such kind of pairs in which both are integers, total number are 29. So 29 such combinations are possible. So right option will be option number B. When any two natural numbers n1 and n2 such that n2 is equal to n1 plus 2 are multiplied with each other, then which digit appears least time as a unit digit if n2 is less than equal to 1000? So what does that mean basically? So start with the first number. So n1 will be 1 and then n2 will be equal to 3, which gives me product 3. Next number will be 2. So n2 has to be plus 2, so that will be 4. So that is 8. Then 3 into 5, 15. Then 4 into 6, 24. Then 5 into 7, 35. Then 6 into 8, 48. 7 into 9, 63. Then 8 into 10, 80. Then 9 into 11, 99. Right? Now here we see 3 is occurring out of the options. So there are 0, 4, 9. Now 0 occurs one time only. Right? 0 occurs as unit digit one time. Now 9 also occurs one time. Right? Now 4 also occurs one time. So we can't deduce a relation from this. Now moving to 10 into 12. So this is 120. 11 into 13. So this will give me unit digit 3. 12 into 14 will give me unit digit 8. 13 into 15 will give me unit digit 5, 3, 15, 5. 14 into 16 will give me unit digit 4. 15 into 17 will give me unit digit 5. 16 into 18 will give me unit digit 8. 17 into 19 will give me unit digit 3. 18 into 20 will give me unit digit 0. And 19 into 21 will give me unit digit 9. Now here I am getting 2 zeros. So for up to 20 I can say 0 is coming 3 times. Right? Now 9 is coming 2 times. Right? 1 over here. Now 4 is again coming 2 times. So out of this, the option 0 is option A is discarded. Right? Now if I write another sequence, or I can say that if I neglect this one, why? Because n2 has been given less than 1000. So that means in that case the value of n1 has to be equal to, the last value will be equal to 999997, right? Because n2 has to be less than or equal to, so that will be next value 998 and then n2 will be 1000, right? So up to this 9 is occurring only one time, because I have to take only up to 998. So I will consider up to this point only. So in this case 4 is coming 2 times. So I can say that option B, 9 will occur least time, because I am considering 2 columns up to 998, which is the greatest possible value of n1, right? A diamond expert cuts a huge cubical diamond into 960 identical diamond pieces in minimum number of n cuts. If he wants to maximize the number of identical diamond pieces, making same number of n cuts to it. So the maximum number of such diamond pieces are, so here the question is, we have been given a large cubical diamond, right? Now we know that to create different diamonds from it, we need to have 3 cuts, because this is a 3-dimensional figure. Now these must be the factors of 960, these 3 factors. So 960 can be expressed as 8 into 10 into 12, right? Because we need to have 960 identical diamond pieces. with minimum number of n cuts. So cuts should be minimum, and this must be factor of 3 factors of 960, right? Now the minimum number of possible number of cuts will be equal to 8 plus 10 plus 12. 8 plus 10 plus 12, so this is equal to 30. Fine. Now, but we need to maximize the number of identical diamond pieces, making this number of cuts. Now, this is a very logical question. So here we need to find that the identical diamond should be the maximum. So in that case, when it can be maximum, so A plus B plus C is equal to 30, right? This is the condition, and we know that in order to make this product to be maximum, A should be equal to B should be equal to C, right? In that case, that can happen only when I assign all these two values to 10. Now 10 multiplied by 10 multiplied by 10, so this is the minimum number, maximum number of pieces which can be produced, so that will be 1000, right? So the right option for this question will be option number A. So 960, we need to have n cuts, so basically we can create a small diamond from here by having 3 cuts. So basically we have to divide 960 into 3 factors. Now the sum is equal to 30, but the question says that we want to maximize the number of identical diamonds. We need to maximize the diamonds by making minimum cuts, right? So these are basically 3 cuts in a 3D figure. So A plus B plus C is equal to 30. But now in order to maximize the number of diamond pieces, it can happen only when A is equal to B is equal to C, but it is equal to 30, so thrice of A will be equal to 10, so 10 multiplied by 10 multiplied by 10, so 1000 number of pieces can be made. The unit digit of the expression 1 factorial whole raised to power 1 factorial plus 2 factorial whole raised to power 2 factorial plus 3 factorial whole raised to power 3 factorial plus so on plus 100 factorial whole raised to power 100 factorial. Now 1 factorial whole raised to power 1 factorial is basically equal to 1 raised to power 1, so unit digit will be 1, right? Now unit digit of 2 factorial whole raised to power 2 factorial, so this is basically 2 raised to power 2, so unit digit will be equal to 4. Now for 3 factorial whole raised to power 3 factorial, unit digit will be equal to 6 raised to power 6. Now we know that cyclicity of 6 is 1. That means 6 raised to power any power will be, give me unit digit as 6. So unit digit over here will be 6. Now 4 factorial whole raised to power 4 factorial. So this is equal to 4 3 12 24 whole raised to power 24. Now unit digit is 4. Cyclicity of 4 is 4. 6 4 raised to power 1 is 4. 4 raised to power 2 is 16. 4 raised to power 3 is 64, so cyclicity is 2. So 24 is divisible by 2, so cyclicity, so this will be, unit digit will be 6. Now we know that beyond 5 factorial, unit digit is 0. So unit digit over here will be 0, and beyond this all factorials will yield me unit digit 0, right? So unit digit will be 6 plus 6 12 plus 4 16 plus 1 17. So unit digit will be 7. So right option will be option number D, right? Anjali and Bhagwat fired 45 shots each. Total 66 bullets hit the target and the remaining bullets missed it. How many times does the Anjali hit the target if it is known that the number of hits per one miss shown by the Anjali is twice that of Bhagwat? So we have Anjali and Bhagwat, right? Total they've shot 45 shots, right? Now hits. Let us suppose Anjali shot X hits. Now we know that total 66 bullets hit the target. If Anjali hit X, so X plus this, so this must be equal to 66 minus X, because total number of hits X plus 66 minus X should be equal to 66, and this is total 90. These are the hits. Now the question says how many times does the Anjali hit the target if it is known that the number of hits per one miss shown by Anjali is twice that of Bhagwat. So this is a ratio question. So total number of hits by Anjali is X, right? And total number of non-hits will be 45 minus X. So I will write this in denominator. Now the question says that this is equal to twice. Total number of hits by Bhagwat will be 66 minus X divided by 45 minus 66 plus X. So this is equal to X minus 21. So in denominator I will write x minus 21. Now by cross multiplication I will get x into x minus 21 equal to 2 into 66 minus x multiplied by 45 minus x. Now if I solve this will be time taking process, so I will just move to options. Now in options I have been given the value of x because we have assumed the hits which we need to find. So for first is 30. So when I put the value of x equal to 30, so this will be 30 into 30 minus 21, 9. On the right hand side it should be 2. 66 minus 30 is 36 multiplied by 45 minus 36, 45 minus 30. So that will be 15, right? So 30 into 30 minus 21, right? Now this is 15 into 2 is 30. So this is 30.9 will not be equal to 30 multiplied by 36. So option A is out of question. Now moving to option B. Option B is 36. Now when x is equal to 36, then this will become 36 into 36 minus 21 is 15 equal to 2.66 minus 36 will be 30 and 45 minus 36 will be equal to 9. Now here it is 36 into 15. Now we'll try to change into, so this is basically 2 into 15, breaking 30 into 2 into 15 into 9. Now 9 into 4 is 36. 36 into 15. Now on both sides 36 into 15. We need not to multiply it. So right option is option number B. Option B is the right answer. Now we can check it also. Now here if I put the value 36. So here it becomes 66 minus 36 will be 30. Now the question says that the Anjali hit the target. It is known that number of hits per one miss shown by Anjali is twice that of Bhagwat. So that means this ratio should be twice of this. Now x is 36 divided by 45. On the right side it will be 30 twice 30 divided by x is 36, x minus 21 or x minus 21. So that will be basically 36 minus 21. So that will be equal to, on left hand side it will be 45 minus x. So that will be 45 minus 36. So that will be equal to 9. And on this side 36 minus 21 is 15. So this becomes 36 upon 9. So that will be 4. On this side it is 2. So it is multiplied by 2. Twice of this. 4 is equal to 4. So this double justifies that the answer is option number B. Right? The only library of a business school has 91 books that are shared among all the students in such a way that every 2 students share a book on organizational behavior. Every 3 students share a book on financial management and every 4 students share a book on operation research. The number of students in the school is, now let us suppose the number of students be x. Now the question says that x by 2 plus x by 3 plus x by 4. So this says that every 2 students and every 3 students and every 4 students share a certain number of books. So this number is equal to 91. Now we just need to solve this. So the LCM will be 12. 12 divided by 2 6. So this will be 6x. 12 divided by 3 4. So this will be 4x. Plus 12 divided by 4 3. So this is 3x equal to 91. This implies 6 4 10 13x should be equal to 91 into 12. Now 13 7 is 91. So x will be equal to 12 into 7. So that is 84. So total number of students are 84. So right option will be option number B. After 2 successive raises, the salary of an employee becomes equal to 15 by 8 times of his initial salary. In terms of percentage raise, his first raise was half of the second raise. Then by what percentage his salary was raised for the second time? Now, let us suppose the employee's first income was I. So after successive 2 raises, the income becomes 15 by 8 of I. Right? Now, it has been given that the first raise was half of the second raise. So this is all the second raise. So first we'll consider the option B, as 82.5 we'll consider later. Now for option B, the first raise will be equal to 30%, right? Because it has been given that the second raise is twice of the first raise. Now 30% is 3 by 10 and 60% is 3 by 5. Now in terms of ratio, this will become the income increases from 10 to 13, and for the second it increases from 5 to 8. So this becomes 50, and 13 into 8, 104. So its income will be 104 by 50. So this will be equal to 52 by 25 of the initial income, but we need 15 by 8. So now moving to option C. So if 50% is the second day, so first days will be 25% and next will be 50%. 25 is 1 by 4 and 50 is 1 by 2. Now in terms of ratio 1 by 4, so the income increases from 4 to 5, and second case from 2 to 3. Now this is 4 into 2, 8, and this is 15. So income will increase 15 by 8. So this is what matches with this. So option C is the right option. The number of digits in the product of 5 raised to power 72 into 8 raised to power 27 is. So we can reduce 8 to 2. So this becomes 72 into 2 raised to power 3 whole raised to power 27. Now this further equals 5 raised to power 72 into 2 raised to power 27 into 3 is 20 into 3, 6. So 27 into 3 is 81. Now out of this, the combination of 5 raised to power 72 into 2 raised to power 72 will yield me 10, because 10 is equal to 5 into 2. So I can write this as 5 raised to power 72 into 2 raised to power 72. Now how many 2 raised to power are left? So that is 2 raised to power 9. Now I can write this as 5 into 2 whole raised to power 72 into 2 raised to power 9. Now this becomes 10 raised to power 72 multiplied by 2 raised to power 9. So this is basically 512. So the total number of digits will be equal to 10 raised to power 72 zeros plus these 3. So then now total number of digits will be 72 plus 3 equal to 75 digits. So the right option will be option number B. Paltry and Sundari, the two bird hunters, went to woods. Paltry fired 5 shots when Sundari fires 7 shots. So here it is Paltry and this is Sundari. So shots, when Paltry fired 5 shots, Sundari fired 7 shots. But Paltry kills 2 out of 5. So Paltry kills 2 out of 5. So that means hits and miss. So 2 out of 5 basically means if 2 shots hit, so miss will be 3, 5. While Sundari kills 3 out of 7. So Sundari kills 3 out of, so miss is 4. So total is 3 plus 2 plus 3, 5, 3 plus 4, 7. Now, but Sundari has missed 32 shots. So Sundari has missed 32 shots means this is a multiple of 8. So we get 32. Fine. How many birds has Paltry killed? So this will also be multiple of 8. Right. This will also be multiple of 8. And this will also be a multiple of 8. So that means Paltry hits 16 shots. Right? So the right option will be option number C. Now we'll check. Now this is 24 into 8 is 56. Now 32 plus 24 is 56. Here it is 16 and this is 24. Into 8 is 40. So 16 plus 24, 40. So basically this, what when Sundari has missed 32 shots, gives us the value of common ratio x. If we consider it at x, so by that we can calculate every other value. The last digit or the unit digit of the expression 4 into 9 square into 4 cube into 9 raised to power 4 into 4 raised to power 5 into 9 raised to power 6, so on up to 4 raised to power 99 multiplied by 9 raised to power 100 is. Now if you see closely, the power of 4 is raised by successive odd numbers and power of 9 is raised by successively even numbers. Now the first combination, this product will have unit digit 4 because the product is 144. Now for every such combination, the unit digit will be 4. You can check it. This will yield me unit digit 4. Every combination of 4 and 9 will yield me unit digit 4. Now how many combinations will be there? There will be 50 combinations because starting for 4, starting from 1, 3, 5, 7 up to 99, and for power of 9, 2, 4, 6, 8, so on up to 100. So this means that 4 is multiplied 4 multiplied by 4 multiplied by 4, so on up to 4. How many times? 50 times. So this basically comes 4 raised to power 50. Now we know that cyclicity of 4 is 2, and the sequence is 4, 6. So that means the unit digit will be, since 50 is divisible by 2, so the unit digit will be 6. So right option will be option number B. PQR are decimal numbers, for example 5.8, and x means the greatest integer less than or equal to x, and a is equal to p plus q plus r, and b is equal to p plus q plus r. Then the maximum value of a minus b is. Now we'll assume some values for this. Let us suppose p is equal to 3.99, q is equal to 4.99, and r is equal to 6.99. Now we have been given that a is equal to this operation p plus q plus r, right? Now this is equal to 3.99 plus 4.99 plus 6.99. So this is basically equal to 15.97. Now this operation means that the greatest integer less than or equal to, so less than the greatest integer is, so this is equal to 15. Now b is equal to, now this operation will be applied individually on each values. So this is 4.99 plus 6.99. So this is equal to 3, greatest integer less than this or equal to this. So 3 plus 4 plus 6. So this is equal to 6 plus 4, 10 out 30. So a minus b is equal to 2, right? So you can check it with some other values also. So the right option will come option B. If a and b are two co-prime numbers, then a plus b and a minus b are always co-primes, have at least one factor other than 1. If a and plus b or a minus b is not a prime number, then their HCF is 2, none of the above. Now let us consider some values for this. Let us consider a is equal to 17 and b is equal to 15. Now these two are co-primes, right? Because these are prime numbers. Now a plus b will be 32 and a minus b will be 2, right? This is a plus b, this is a minus b. Now here you see that 32 into 2 have their common factor 2. So their common factor is equal to 2. Now let us consider some two other values, 7 and 4. A is equal to 7 and b is equal to 4. Now these are also co-primes, but these are not prime numbers, right? So in this case 7 plus 4 is 11 and 7 minus 4 is 3. Now these are also co-primes because they don't have any common factor, right? And these were prime numbers. Now we'll look for options. Now if you see closely option number C, if a plus b or a minus b is not a prime number, right? Now these are not prime numbers, so their common factor is 2, so their HCF is 2. So right option will be option number C is the right option. Thank you for today's lecture. Bye bye, take care.